Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving you today, as it is every day here in my virtual classroom. Step on inside as we jump into the Chapter 3 Test and Cumulative Assessment in the Big Ideas Math Integrated Math 3 textbook. We're wrapping up our stuff on polynomials. We just came off the Chapter 3 review. You can find that in the playlist down below, and that's where I do a little more teaching as I do. This one's a little less teaching, a little more doing throughout these problems. It's expected at this point that you kind of know what you're supposed to know, and then you're trying it for yourself. You can compare to my answers, things like that. I just hope to goodness that I'm right. Bring your graphing calculator alongside, especially when I do addition and subtraction. I always tend to have problems with those. But jump to the description section down below. You can find the PDFs to each thing. There's the test and the cumulative assessment. Sometimes people just work on the test. Cumulative assessment covers everything with chapters 1 and 2, as well as 3. I think 9 more questions on top of the 12 that we're going to have here. So 21 questions in total. I'm going to give you other items such as the PDF too, not just these parts, but also graph paper if we're going to need any graphs, and also just the timestamps for each individual portion. So without further ado, we're going to go ahead and get started. That is not what I'm looking for. I'm looking for that. Aha, we got it. Okay. On numbers 1 and 2, and these aren't necessarily in order of section or anything, so these just show up as they do, okay? And I've noticed chapter tests can sometimes be a little bit harder with material compared to the review stuff, so we'll see. So far, it doesn't look like it. On numbers 1 and 2, write a polynomial function f of least degree that has rational coefficients, a leading coefficient 1, and the given zeros. So again, less teaching, more doing. I'm going to go ahead and jump start in this one. I'll do the way that I generally do these ones with this. I like the plus or minus 2 there. Obviously, we need a least degree of 3. So I'm going to let x equal 1 plus or minus root 2, subtract the 1 over, and expand by squaring both sides. This will get rid of my radical. Negative root 2 squared, or root 2 squared is 2. Subtract the 2 over, you get x squared minus 2x minus 1 equals 0. This is one of your factors. The other factor here is going to be x minus 3. So we'll write an equation out that says f of x equals x minus 3 times x squared minus 2x minus 1. Now the book has an alternative version to expanding this, which is totally fine. Still very good. This just goes a little bit faster for me to get here, but you should get to the same spot. Now I'm going to distribute x into these 3 and negative 3 into these 3 here. Just make sure when you're distributing the negative 3 that it is the negative that is distributing in. And when we combine like terms, we get that. Here's to hoping that that's right. Number 2, negative 2 and 4 and 3i. Given that we have 3i for rational coefficients, we'll also need negative 3i. So here's one, here's another, here's a third guy being the plus. Let's give it that minus as well. I'll do it kind of more book fashion this time, just because these factors are going to be pretty easy to work off of. X plus 2 was from root of negative 2. X minus 4 is from the root of 4. We got x minus 3i times x plus 3i. Now, this is a difference of 2 squares over here. We'll get to that portion. This is just standard foiling. Let's just do any 2 at a time, these 2 here. We'll get x squared minus 4x plus 2x minus 8. Then this becomes an a squared minus b squared case. Now x squared is here, minus 9i squared. I squared is negative 1, minus negative 9 is plus 9. So it's a sum of 2 squares, really. Let's distribute the x squared into these 3 terms first. And then let's distribute the 9 into those 3 terms. And now we will combine like terms where we get a quartic function. And we expected a quartic function here. We expected a cubic function on the previous one, and this is because of the number of roots that we have. This is something that's a part of the fundamental theorem of algebra that we want to make sure that we always take care of. So 1, 2, 3, 4 solutions, plus 3i, negative 3i. 1, 2, 3 solutions, 1 plus root 2, 1 minus root 2. This was a cubic with 3 solutions, a quartic with 4 solutions. Okay, let's jump to numbers 3 through 6 where we find the product or the quotient. Division is going to be a totally different animal than multiplying. It's not just opposite, I guess it sort of is, but we can treat it differently depending on what we're doing. Now we just came off some multiplication. Doesn't mean there ain't more to be had, so let's go ahead and check this one out. It's going to be a pretty large polynomial, all told. X to the 6th times x squared is x to the 8th. Remember, we add our exponents. So we get those 3 first. Negative 4 will now distribute into these 3. Like that. and combine like terms. And by the way, I'm writing everything in standard form. I don't know if that's... Oh, no, nothing to combine, guys. That's it. And this is in standard form as well, descending order of degree. We're all good. First step is the final step. Thank you for the question. Number 4, we have division this time. So in number 4, we have... Excuse me. Okay, because this is a quadratic and not a linear factor with a 1x, we'll use long division on it. Now, I did not leave space for the 0x squared. That's up to whether you want to do that or not. I'll just note to not combine terms that aren't alike, right? I can only combine x's with x's, not with x squareds. X squared goes into 3x to the 4th. 3x squared times... I gotta fix my hiccups. Give me 1 second here. Okay. I was going to say 1 times 3 is 3, and x squared times x squared is x to the 4th. So when we multiply these as 3x to the 4th, negative 2 times 3x squared is negative 6x cubed, and 1 times 3x squared is 3x squared. Now, we subtract these results. So these go away. Subtracts the negative becomes addition. Negative 2 plus 6 is 4, so 4x cubed. Nothing's combining with 3x squared up here, and 3x squared is going to subtract out, so negative 3x squared. And then the negative x and negative 1 are subtracting 0. So that's what should result in that. No matter which way you have it, placeholder of 0 or otherwise, that's what we should get. X squared goes into 4x cubed, 4x times, positive 4x. When you multiply these, once again, those two should cancel out, and they will. Negative 8x squared and plus 4x. And now we have a combination of any of these things. These will combine. Negative 3x squared plus 8x squared. Remember, subtracting the negative is 5x squared. Negative x minus 4x is negative 5x, and there's a negative 1. This is the last time we can do the division on it because this is x squared, this is x squared. Anything of lesser degree will not be able to go into it and will be a part of the remainder if a remainder exists. So we'll have, and there will be a remainder, 5x squared minus 10x plus 5. Subtract these results here. Negative 5x minus negative 10x is positive 5x. Negative 1 minus 5 is negative 6. This is our remainder, the 5x minus 6. The quotient portion is 3x squared plus 4x plus 5. So what is this divided by this going to equal? It's going to equal 3x squared plus 4x plus 5 plus the remainder of 5x minus 6 all over x squared minus 2x plus 1. Remember, the divisor is still the denominator of this fraction that it could not divide out from. Okay, okay, let's jump to... This next one's division as well. I can probably fit it here. It's fine. It's fine. We're good. Number 5. This one I'm going to use synthetic division on. I can use long division, just synthetic is quicker, and when it's appropriate to be able to use it, like here, I shall. This is divided by x plus 2. This is a linear factor with a 1x involved. If x plus 2 is the factor, then negative 2 is the root. So we'll set it up like so. I got a 2x cubed, negative 3x squared, 5x, and a negative 1. Here, if there was a term missing, we must throw those zeros in because synthetic division does not see variables. Bring the 2 down, multiply by negative 2, we get negative 4. Add those, multiply by negative 2 here, add those, multiply by negative 2 here, and add those. This is the remainder. The quotient here is 2x squared minus 7x plus 19. That is not a 7. I was thinking of the 19. The remainder is 39, and we shall divide it by the x plus 2, the part that it could not divide by. I should qualify that as enough room. We'll move forward to number 6. Number 6 is multiplication. We have 2x plus 3 quantity cubed. We are in the camp, personally, of binomial expansion. So a plus b quantity cubed becomes a cubed plus 3a squared b plus 3a b squared plus b cubed. That becomes 8x cubed plus, 2 squared is 4, times 3 is 12, times 3 is 36, plus 3 squared is 9, times 2 is 18, times 3 is 54, plus 3 cubed is 27. So there is our cubic binomial expansion, probably want to have that at least that one step in between, make sure everything's good. Otherwise, there's some you could do mentally. It's just not 2x cubed plus 3 cubed, right? That would be very short-sighted of this problem. Okay, number 7. We have the graphs of f of x equals x to the fourth and g of x equals x minus 3 to the fourth that are shown. The questions, part A, how many zeros does each function have? Explain. Now, zeros are x-intercepts. When you're looking at the graphs themselves, look at where they touch the x-axis. It only touches at their vertex right there tangentially. So for part A, each function, f of x and g of x, each have 1, 0. Each have 1, 0. Another word for 0 is x-intercept, solution, root, things like that. Explain. That is where they touch the x-axis. Let me type this. They only touch the x-axis once. They only have one x-intercept each. At their vertex, at their respective vertexes. I don't know if it's vertexes or vertices in this case. I just want to kind of talk about, I'm talking about the word vertex in that way. That's the explanation. All right, part B. Describe the transformation of f represented by g. I'll also type this one out. G, you can either look at the graph or look at the equation. If you look at the graph, you can see it's 3 units to the right of it, and that's exactly how I can explain it. The graph of g is a translation 3 units right of f. The equation also indicates that whenever there's something inside of your function, the part that's being raised to the fourth power, it's going to be taking the opposite of what we're doing. The minus 3 means we're going 3 to the right, like that, and that's the translation. Part C, determine the intervals for which the function g is increasing or decreasing. G, the blue graph, decreases all the way until x equals 3, and then it increases after x equals 3. So as far as its increase and decrease, g increases on the interval when x is greater than 3, and it decreases on the interval when x is less than 3. And that does it for its entirety. That is its end behavior of its graph. F is the same way, only it's less than 0 and greater than 0 for increase, decrease. Okay, number 8. Totally different question. The volume V in cubic feet of an aquarium is modeled by the polynomial function written there. So let's write that. V equals, or V of x equals x cubed plus 2x squared minus 13x plus 10. This is volume of an aquarium, where x is the length of the tank. The length of the tank. Part A, explain how you know x equals 4 is not a possible rational 0. They're not even talking about testing it. They're saying what makes it not possible. So in part A, that's because it doesn't belong as your factors of p over q, factors of 10 over factors of 1. 4 is not a factor of 10 over 1. Your options, and I think we're going to have to do some stuff with it, but your options are plus or minus, and all these numbers divide by 1. So what are factors of 10? 1, 2, 5, and 10. 4 is not among them. It's not one of the possible rational zeros that can exist in this set. Now, we never got to teach deeply as to like why these are the ones to test and things like that. I do a lot of stuff with my students like that. We do some warm-up stuff. The whole class gets involved. And it's not something we really want to spend time doing here, so I'll leave it. Part B, show that x minus 1 is a factor of v of x, then factor v of x completely. To show that it's a factor, you're going to want to use synthetic division on that because factoring is a part of the division and breaking this thing down. So if x minus 1 is a factor, x minus 1 is factor, use x equals 1 as root. So we're going to divide by x minus 1, right, or factor out the x minus 1, but 1 is the root in synthetic division. We have the numbers or coefficients 1, 2, negative 13, and 10. And let's go very quickly on that. Basically what we're looking for is a remainder of 0, and we'll get that. With the remainder of 0, x minus 1 was indeed, again, one of those factors. The other factor here looks to be x squared plus 3x minus 10. They ask us to factor completely on part B, so we'll continue forward a little bit more. X squared minus 3x plus 10 factors to x plus 5 times x minus 2. And that should be the full setup there on part B. Part C says find the dimensions of the aquarium shown. Based on setting these equal to 0, not equal to 0, what are we looking for? Oh, volume is 3. setting these equal to 3. Oh, hold on a second. This is kind of a mean question because you don't want the factored one equal to 3. You want the original thing equal to 3. So as great as this was as a factor, it literally means nothing for us in this problem. Here's the problem, and I'm running into this right now. Here, let me actually write this. Let's say you did this. See, I don't want to set it equal to 0. The volume's not 0. I want to set it equal to 3. I don't know if you noticed this. It says the volume down here. It's in small print. The volume is 3 cubic feet. All right, let's say we did this. Factorization is really good in zero product property. I got to teach you something here. Factorization is really good in terms of zero product property. Set it equal to 0. Either this equals 0, that equals 0, that equals 0. If this equals 3, when it multiplies, there's no 3 product property. It's not either this equals 3, this equals 3. It doesn't work like that. It needs to equal 0. So you might say, we'll subtract 3 over, set it equal to 0. Great, but it's no longer a product now. It's a product here minus something. It's a difference. We got to go back to our original problem. This is no good for what we need. You just have to expand this out again. And what does it look like expanded out? The original thing. So we have to go all the way back to this. All that factorization literally meant nothing for the problem. We will subtract 3 over. Like that. And we're going to redo the factorization process all over again. Literally. All over again. Where now our p's over q's are not factors of 10 over factors of 1. They're factors of 7 over factors of 1. So plus or minus 1, plus or minus 7. Those are our only options here. So kind of an interesting problem. Let's test some numbers. 1 plus 2 minus 13 plus 7, that's not 0. Negative 1 plus 2 is 1, plus 13 plus 7, that's not 0. 7 cubed, oh, let's use the calculator for this one. Actually, let's try synthetic division. Let's see if we can get a 0 remainder out of that. And if we can't, we're just going to go to the graphing calculator and find the irrational solution set it is, I guess. So let's try 7 with 1, 2, negative 13, and 7. We need a 0 remainder. So multiply by 7 now. Ooh, that's not going to work. Okay. Scrap 7. Let's try negative 7. I don't think this is going to work either. Maybe no rational solutions to this guy suddenly. Negative 7, negative 5, 35. Yeah, that's looking very moot here. 22 and negative. Yeah, that's not going to work either. So no rational solutions exist for this one. We have to go to the graphing calculator and take a look at what the heck this problem is doing for us now. So on this, we're going to go to x cubed plus 2x squared minus 13x plus 7. Unless I totally missed something, 1 or negative 1 needing to work here. Invalid window? Hold on a second. Invalid dim normally means invalid window. I got to look at what's going on here. Let me try and fix whatever's happening with that. You know what? I know what's going on. I have stat plot turned on, but there's nothing to graph. Okay, let's go back. Okay. So it hits some values right here, right? Now it seems... Let's see what that 0 was on the left side. Is that not 1, 2, 3? Is that not negative 5? Maybe it's not. It's not exactly. No, it's not exactly negative 5. Okay. So a few irrational solutions, right? Now there's a 0 right here and a 0 right here. Based on our equations, I want to show you this here. Based on our equations, the factored form will still help me in some sort of way. My x's need to be not just positive, but large enough so that when I subtract 1, it stays positive. Large enough so that when I subtract 2, it stays positive. So when I look back at this window range, this number looks like it's less than 1. A number less than 1 minus 1 is negative. A number, they're less than 2 is negative. This number is a little bit greater than 2. This is the 0 that I'm looking for here. This is the one that I'm looking for. So let's find that 0 by choosing a number somewhere between 0 and 5, and I got to get close to it. Close enough. Where is my cursor? I want to make sure I'm going in the right direction here. There it is. All right, let's get near it. And it's looking to be 2.312 something, something, something. So let me just write that. X is about 2.313. Okay. So there is my x value that we found. That is our solution, not our solution to the whole thing. We got to find all the dimensions of this, I think. Yeah, find the dimensions of the aquarium shown. So let's go ahead. I don't know where our expressions are for the aquarium. That's the only problem. Oh, the x minus 1, x minus 2. Okay, so our volume is this, this, and that. Now, I don't know which one's representing what. It says x is the length of the tank. X is the length of the tank. Well, these are our factors here. If x is the length, let me think on how we determine the width and the height, because none of these are factors that are x, right? We can't break it up in that way. If x is the length, let me think on that a little bit. I thought about it more, and I don't know how to represent. Here's the thing. If x is the length of the tank, then we wouldn't have a way to represent width and height in any sort of certain way. The only ones that we have as a for sure is this expression here that's in factored form. I'm going to use those. I don't know what else to say. They say x is the length. X is something I need to solve for, but I'm going to use that number into these here. So I'm going to call the, I don't know which one's length, width, and height, though. That's the only problem. I know length needs to be longer than width. You know what? Just let's find the dimensions. The dimensions here, we're going to have 2.313 minus 1, 2.313 plus 5, and 2.313 minus 2. So we're going to have dimensions of minus 1 is 1.313 feet by plus 5 is 7.313 feet by, and then 0.313 feet. I have no other discernible way in understanding how x is used. And remember, these aren't x's. These are like multiplication. I don't know other ways to discern that other than solving for the x that we have. X isn't specifically length. Yeah, I have no idea. That's what I'm going with. I'm hoping that that's kind of one of the right answers off that. Kind of a weird question as a whole, because I guess we did use factored form, but we didn't use it to solve with. Anyway, I'm going to go ahead and move forward. Let's go to number 9. One special product pattern is a minus b squared equals a squared minus 2ab plus b squared. Using Pascal's triangle to expand a minus b quantity squared gives you 1a plus 2a times negative b plus 1 times negative b squared. Are the two expressions equivalent? Explain. Yes, they are. Yes. I mean, explain. I mean, well, the thing on Pascal's triangle is it's 1, 1, 1, 1, 2, 1. It's right there. So row 2 gives us what we need. First term, second term, third term coefficients that multiply for this a minus b quantity squared. That being said, they're almost going full bore. When they say 1a squared, they're saying 1 times a squared times, and they're even missing this, b to the 0. I know there's no reason to write that because b to the 0 is 1, but same reason you don't need to write a. Now, they're treating b as negative b, if you will. Normally, I write a minus in front. I'm going to go ahead and put it right there. And by the way, this should be negative b to the 0 then. Plus, this would be 2 times a to the first times negative b to the first. I know they didn't put those, but I'm going full bore on it once again. Plus 1 times a to the 0 times negative b to the second power. So that's 1 times a squared times 1 plus 2 times, plus negative 2 plus negative 2 times a times b, right? Negative b multiplies with that. Plus 1 times b squared. 1 times 1 is 1, and that gives you 1a squared, which is a squared. This is minus 2ab plus b squared. I don't really know what else to say on that. I tried to get as expansive as possible. They were pretty much there. Ultimately, it does simplify to that. That's how perfect squared trinomials are played out. I tried. Number 10. Can you use synthetic division procedure you have learned in this chapter to divide any two polynomials? Explain. Not really in full, no. There are some that you could break it up into multiple factors. I think to just answer this question here, you can only use it, and I'm not going to get in full bore teaching. Once again, full bore is now my new phrase. No, you can only use it on linear factors that appear in x minus k form if k is the root. Now, that being said, there are instances, and I haven't done it with a non-zero remainder, but I've done it with a zero remainder. There are instances where you can take a, how do I say it? Sorry, give me a second. You can take a quadratic, like x squared minus 5x plus 4. You can take a quadratic here and factor it into, say, x minus 1 times x minus 4 like that, and divide them separately. Divide by x minus 1 first with synthetic division, get the result. Then divide by x minus 4 second with synthetic division, get the result. Only if I have a zero remainder am I comfortable in doing that, but I'd rather use long division anyway. There's another set where, this is a linear factor, great, but if you have something like 2x plus 1, you still have to be careful because negative 1 is not your root. Your root is 1/2. The 2 factors out. The 2 is something you have to divide first or second alongside what you're doing. Negative 1/2 is your root. So those are ones you can use synthetic division on right here because it is a linear factorization and 2 is all to divide beyond that. And I'm comfortable with it. I just don't prefer it personally. I'd rather use long division in those scenarios. So you can, but anything else, use long division. Otherwise, use long division. And it's really a recommendation to do so. So that's why you kind of have to know both of them. Well, I'll say this. You have to know long division. Synthetic division is a great, very useful, very, very efficient and effective method to use in a lot of different scenarios that long division is not even employed. Number 11. Let T be the number in thousands of new truck sales. Let C be the number in thousands of new car sales. During a 10-year period, T and C can be modeled by the following equations where T is time in years. I'm going to copy and paste that one. Just a longer thing to write. Kind of blurry. My bad. Whenever it's smaller print, that's going to happen, but hopefully you can still see that just fine. Part A, find a new model S for the total number of new vehicle sales. Well, I'm going to combine like terms if that happens. So S is all of T plus C. Now, I can add down these lists perfectly, which is nice. 23 plus 14 is 37, so we get 37T to the fourth. These subtract together, so negative 660 T cubed plus 35 plus 24 is 59. So 59,000 T squared minus 13,400 T plus 17900. I think all those numbers are right, and that would be my part A, my model S, if you will. My model S. Part B is the function S, even, odd, or neither. Explain your reasoning. Okay, interesting. I thought we were going to graph or something like that. It's even degree. That doesn't mean it's an even function. So it's in neither case. This is because if I substitute, the idea is S of negative T. If I substitute a negative T into here, this stays positive, sure, but this one turns positive. Negative T to the third is a negative number, so this becomes plus 660 T cubed. This one stays the same sign. Anything that has even degree things right here will maintain the signs that they are. Anything that is odd degree will change its sign. And the idea is if you get a combination of some things that stay the same, some things that change. So not the same, not same, not exact opposite. That's my explanation there. For an even function, it needs to be exactly the same. For an odd function, it needs to be exactly the opposite, where you can factor out a negative from there, and then you get the same thing out when the negative is factored. And that's not the case. For opposite T's, we're not getting exact opposite S's or whatever. So even, odd, or neither, none. Even degree, sure. The leading term is an even degree polynomial, but not an even polynomial. Okay, again, no graphing on that one. Number 12. Your friend has started a golf caddy business. The table shows the profits P in dollars of the business in the first 5 months. Use finite differences to find a polynomial model for the data, then use the model to predict the profit after 7 months. So let's copy and paste that one as well. Let me this time get a better image. I'm going to use the PDF version that I have, not the one that you're seeing on the screen. So give me a second. You'll compare it to the other table thing we have and go, oh wow, a world of difference. It's from 144p to 1440p or something like that. Look at that difference right there. Wow, 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 wow. Okay, so with this in mind, we're just going to compute differences between these. The T's have consecutive constant differences between them. So here we are subtracting 2, then adding 4, and then 16, and then, 34. I think those are correct. Then from negative 2 to 4, we're adding 6. And this is 2, and this is 18. And then this difference here is minus 4, and then we have a plus 16. And then, what? Do I have enough in between to work this? I only have one more term to work off of. from negative 4 to 16 is, well, you know, it's 20. Do I have enough things to work off, or did I already screw this up? Plus 16, plus 34. Were these supposed to be the same? What do I do? It says use finite differences to find a polynomial model for the data. I'm only going to have to assume that based off this thing here, that this is going to be constant throughout. I don't know any other terms beyond this one, so I'm going to have to assume this is a quartic. This is a very interesting kind of question because I don't have anything else to go off of. I don't know if this is a constant difference between any other two terms or not. Oh, that's not plus 2. That's plus 12. I always do this all the time. So let's change that again. Plus 12 plus 18. Oh, my goodness. I do this so often. I do this so often, guys. It is sad. It is abysmal. There's my thing. Okay, it's a cubic. Okay. I can't add to save my life, literally. It's the easiest kind of addition, too. It's not like a very treacherous kind. All right, so from there, constant third degree, and it's a cubic. So what we're going to do is plug these into the calculator. I'm going to go to my stat and edit right here and type in my x's, or t's. And over here, my p's, 4, 2, 6, 22, 56. It is so sad that I can't do that stuff. Okay, so we are going to do cubic regression. We'll do stat, calc, cubic regression of that. And we get these numbers here. Now that C value, that looks like scientific notation. It's not 1.7. It's 1.7 times 10 to the negative 11th power. I don't know what it's doing there, but that's basically 0. So there's no C term. As far as what we're going to write here, this is a P of T equation. Our A is 1, B is negative 3, C is 0, D is 6. So I'm going to be writing here P of T equals 1T to the third power minus 3T to the second power plus 0T plus 6. So there is our model for this guy. Okay. Use finite difference, then use the model to predict the profit after 7 months. Now we substitute 7 into here, and this will be 7 cubed minus 3 times 7 squared plus 6. Let's see if I can do this one in my head. I can multiply significantly better than I can do any addition or subtraction, clearly. So this is 343 minus 49 times 3, which is 147. Uh-oh, I have to do subtraction now. Plus 6. Let's start with 343. Let's start with these two. Negative 147 plus 6 is negative 141. And 343 minus 141 looks easier. Is it, though? Is it, though? That answer is 202. So if that number is 202, what's the context of the situation that we have to put in play? This is profits in dollars after 5 months. So after 7 months is $202 of profit is the prediction. And that's an extrapolation because we only have it for the first 5 months. Who knows if this cubic function does what it's supposed to do there. All right, so pardon me once again for this sum and difference thing. I must have just seen this as a 6 or something. I have no idea what happened. But guys, we're going to go ahead and jump into now the cumulative assessment. So if this is what you're here for, awesome. If you were only here for the Chapter 3 test, then let's see. Otherwise, let's look at the cumulative assessment, the next couple pages down the list. And here we go. We have 9 more questions to do. We're going to start with number 1, and this can be from any chapter among 1 through 3. This looks like it's from chapter 3. Number 1, the synthetic division below represents f of x divided by x minus 3. Choose a value for m so that x minus 3 is a factor of f of x. Justify your answer. So I have 3 given my root, and then I have constants or coefficients 1, negative 3, m, and 3. I'm going to need a remainder of 0 here, ultimately. So bring down the 1, multiply by 3, add that together, multiply by 3, add that together, multiply by 3, and add this together, and we get 3m plus 3. Now, we need 3m plus 3 to equal 0, and what value of m will give us that? That's what will make x minus 3 become a factor. Subtract 3, divide by 3, and you get m equals negative 1. Now, they asked what value of m. If they were asking what the function needs to be written as, the original one right here, the original function would have been f of x equals, this would be x cubed minus 3x squared minus x plus 3. Just letting you know. But that's the answer there. The m value is negative 1. Okay, let's go to number 2. Analyze the graph of the polynomial function to determine the sign of the leading coefficient, the degree of the function, and the number of real zeros. Explain. So, The sign is positive. This, first of all, it's an odd degree function. One that would start down and finish up like that would have to be odd degree. Even would be down, down, or up, up. This is down, then up. The fact that it starts down and finishes up also means that it's positive. So the sign of the leading coefficient, for number 2, the leading coefficient is indeed positive. The degree is, now we can't guarantee degree, but what we can do is get a least value. And I'm sure this will be the answer from what it is. It's based off it's based off really number of turns. This thing turns once, twice, 3 times, 4 times. So at minimum, this has to be degree 5. A degree 5 polynomial can turn as many as 4 times. So the degree is 5. At the very least, that's an odd number. 7's possible. 7's possible. It is. 9 is possible, things like that. If we're looking for this actual answer thing, we're looking for a quintic degree on that one. The number of real zeros on this thing is based off of, well, if it's degree 5 and it hits 1, 2, 3, 4, 5 times, then all of them are hit as zeros. So number of real zeros, there are, all 5 of them are real zeros. If it turned 4 times to make degree 5, and if somehow instead it did, so let's say it did this, let's say it shifted up more, 1, 2, like that, same graph but shifted up, and it only hits once, there's only one real zero. The other 4 that come in conjugate pairs, by the way, the other 4 would have been imaginary in that case. So I think that's the only stuff that they're asking in this stuff. I explained them out loud. I hope you're good with the explanations. Did that answer everything? I think so. All right, let's go to number 3. About 52,300 people live in a 3-kilometer radius of a city's center. This doesn't look like it's out of Chapter 3. I think Chapter 1. To determine 10 years ago, the population density in this region was about 1,750 people per square kilometer, which statement is, not true. So first of all, we got a density, 1,750 people per square kilometer. We have a population of 52,300 people. And what we have to figure out now is that area of that circular city center. It's got a 3-kilometer radius. So the area is pi times r squared. 3 is in kilometers. So this will be 9 pi square kilometers. So we have all the values. I don't know if I want to make sure that that works. I want to see what, I'm going to use the calculator here. Let's see what 52,300 divided by 9 pi gives us. Let's hope it's 1750. So 52,300 divided by 9 pi. Well, it's not exact. So we'll see what's going on with that. It says 10 years ago. Got it. Okay, so hold on. Let me go back to the problem. I was like, why are they giving us all the information? So this is now, and this is 10 years ago. Okay, let me go back to that calculation. We still need that number. So the density now is about 1,850 people per square kilometer. Okay, I just wrote that down. Okay, so this is the now. This was the 10 years ago. Let's look at what they're asking. Which statement is not true? The area of the region is 9 pi square kilometers. That is true, so I won't circle it. That is true. The current population density is about 1,815 people per square kilometer. That is also true. So we're going to do that. 10 years ago, well, okay, I haven't answered this one yet, but I look at D. The current population density is less than it was 10 years ago. Not true. It's more. It was 1,750. Now it's 1,850. So this is the not true one. Let's look at what the 10 years ago was talking about. 10 years ago, there were about 49,480 people living in the region. In order to do that, you take 1,750 and multiply by 9 pi. So let's see that that should be true. Times 9 pi, 49,480. So that's the number. So that is true. Therefore, it's not the correct answer. And the correct answer there is D. Okay, number 4. A parabola passes through the point shown on the graph. 3, 1. It passes through 3, 1. The equation of the axis of symmetry is x equals negative a. Which of the given points could lie in the parabola? That's one question. If the axis of symmetry was x equals a, then which points could lie in the parabola? That's another question. Explain your reasoning. Okay, I'm probably going to explain this out loud. I'm going to call this part A here and this one part B. So part A, which of the given points could lie in the parabola given how it currently looks? Here's our part A. Let's go ahead and copy and paste that graph. Again, it might be a little blurry. We're assuming that A itself is a positive number, meaning negative A is a negative number. And that's important because if A was 0, I mean, we assume it looks like as it does, to the left of the y-axis. Because if A was 0, then reflecting right across this would go from 3, 1 to negative 3, 1. But that's not the case here because we're not on the y-axis for this axis of symmetry. The thing that I'm thinking about that is if we did have one on x equals 0 and this parabola, went there, then it would go from 3, 1 to negative 3, 1, which means this point needs to be farther left than negative 3. This needs to be less than negative 3, meaning a bigger negative number, comma, 1. So it can be negative 4, negative 5, negative 6, something like that. So for part A, and that's a less than symbol right there, part A, negative 3, 1 is actually out. This is in, and this is in. So negative 4, 1, and negative 5, 1 are possible. Negative 4, 1, negative 5, 1. Based on the reflection, it's reflecting farther out. The distance from 3 to a number more than 0 is going to be a number that's more than 3. So it needs to be more than 3 away from an already negative number. It's at least going to be those. Part B would be taking the same thing and, well, flipping it over. So x equals a. Well, I don't know how to do this because I don't want to flip the whole graph over. But you get the idea of the graph. It says if the axis of symmetry was x equals a, and assuming we're still hitting 3, 1, right? So x equals a is now on this side. So positive a. We are still hitting 3, 1. I assume we're hitting it to its right. I don't know that as a certainty. Maybe we can talk about that after. But if we are hitting it here, that means we're reflecting something from positive. Oh, let's see. That's not necessarily true. It can be a negative number, but it has to be it has to be greater than negative 3, right? It can maybe look like this even, but that other side, it needs to be a negative number that's greater than negative 3. So negative 2, 1, I believe could apply. So could 0, 1, and so could 1, 1. I don't see why it couldn't be any of those three just being on that other side when it comes to distance. We don't know what size A is, but as long as it's not negative 3, I believe we're good. There's no reason that I don't think that no reason I think it can really not be anything else. So anyway, that's my understanding of that. So I can say negative 2, 1. What is that? Negative 1, 1, and 0. So 0, 1, and 1, 1 are possible. Okay. A little slower on those problems. I have to kind of think about what they're asking as a whole. The cumulative assessments are a little different, right? They ask questions a little differently. It's a little more exploration, a little more multiple choicey. Number 5, select values for the function to model each transformation of the graph of f of x equals x. Select values for the function. Okay, so f of x equals x, and now g of x equals, we're going to put something here, let's see, x minus boom plus boom. So I'm going to kind of do what they did and give myself a little, let's see, I'm trying to find the color that's similar to theirs. I guess like this. Kind of similar. All right, we're going to put in some blanks here, all right? So for A, the graph is a translation 2 units up and 3 units left. So 2 units up would be a 2. I'm going to kind of just write them right underneath if that's okay. 3 units left, we're subtracting, but it's got to, remember, it needs to look like a plus to go left, so it's going to be negative. So we got to subtract negative 3. It'll end up saying x plus 3. But that's what will be there. You can't put nothing here, otherwise this thing wipes out. So this thing's just going to be a 1, right? There's no vertical stretch, no change, no stretch, anything like that. So that would be A. B, and I hope it's okay that we're writing right underneath. I got to do something to encourage that more. Let's see. Let's do a different kind of color. Kind of like that, okay? So just going right down the line. All right, that's kind of weird, but anyway. Because I don't want to keep rewriting them. All right, B. The graph is a translation 2 units right and 3 units down. 2 units right and 3 units down, given that's still a 1. So g of x equals x minus 2 minus 3. Part C. The graph is a vertical stretch by a factor of 2, followed by a translation 2 units up. This is going to be a 0 because there's no horizontal translation. D. The graph is a translation 3 units right. It's positive, well, minus 3. And a vertical shrink by a factor of 1/2, followed by a translation 4 units down. Should be that one. So those should be the answers there. I'm not writing them as full equations. I hope that's okay. They said find the numbers that go there, not write the equations for them. So that's what I'm doing, just kind of filling them in. Okay, number 6. Which description represents the solid produced by rotating the figure around the given axis? Which description represents... Okay, if we rotate around this axis here, we are going to have a cone. So it's going to, kind of look like that, whatever. It's a cone like that, kind of party hat. The radius would be 6. The height of the cone would be 8. So a cone with a height of 6, radius 8, no. Cone with a height of 8, radius 6, yes. It can't be a pyramid because this thing revolves around with circular edges. It can't be any sort of prism or pyramid. It's going to have to be a cone or a sphere or a cylinder or something like that. It's going to be B. Okay, number 7. Classify each function as even, odd, or neither. Justify your answer. I'm going to justify my answer. There's nothing I have to say for 6. Well, cone with height, hold on. Height equals 8 and r equals 6. All right, number 7. All right, we have A. Now, I stated in my previous review that I'm going to do these polynomials significantly faster here, and I'll show you what I'm going to do for each of them. It's actually super fast. I'll explain it out loud right now. Our goal is to, and we saw this on part of the chapter test, I believe. Our goal is to substitute negative x into each of these polynomials. If when substituting negative x, first of all, when substituting negative x, raising a negative x to an even power will leave you with a positive x to that power. Raising a negative x to an odd power will turn your term negative. Now, that means it'll change its sign. So, an even function has the exact same expression as the original, whereas an odd function has the exact opposite when it comes to sign changes, things like that. A neither is a neither. Now, even functions can be made by polynomials if they have all even numbered exponents for their variables. Odd can be done with all odd. Neither is neither. For polynomials only, I can just alone look at these. There's only one term. It's an odd degree. Therefore, this will be an odd function. On part B, this is degree 3 and degree 1, both odd numbers. This will be an odd function. Now, you can work out what the stuff is all you want. You probably should. I just said I'd do this quickly. We have a combination of an odd degree with a couple even degrees. This is degree 2 and degree 0. This makes this a neither. It'll have some combination of switching some signs but keeping some signs the same. One term is even. That'll make it also even. It'll keep the sign the exact same. 2 times negative x to the 4th is still 2x to the 4th. Both odd termed will be an odd function as well. By the way, odd means symmetric with the origin. Even means symmetric with the y-axis. This is even, 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 and a constant is even. This will be even right here. So my explanation is based off the degrees of the exponents. Obviously, the work of substituting x, we've done a bunch of it, and I'm going to leave it at that. I'll go as quickly as I feel I need to, and that's my need right there. Number 8 also looks to be from Chapter 3. The volume of the rectangular prism shown is given by that which polynomial represents the area of the base of the prism. So we have v equals 2x cubed plus 7x squared minus 18x minus 63. By the way, I don't know if it's cheating or not. This looks like it's factorable by grouping. I want to show you both. I want to show you by factoring by grouping that you can get an x squared out and get 2x plus 7. Factor a negative 9 out and you get 2x plus 7. And, whoops. And that factors into x squared minus 9 times 2x plus 7. This actually might be the slower way to do the problem, believe it or not. Because x minus 3 is the height that we have. So let me write that. Height equals x minus 3. I don't know if you see that in the diagram. Height is x minus 3. but we need the length and the width to make the area. The reason why this is slower, x plus 3 is the other factorization here, is because I now have to multiply x plus 3 with 2x plus 7 to figure that out. This is our length and our width to make the area of the base. This will be 2x squared plus 6x plus 7x plus 21. So this is the answer. We're trying to find that answer here. 2x squared plus 13x plus 21 is this one. It's written not in standard form for whatever reason. So the answer is C. Like I said, that was probably the longer approach, but I wanted to show you that it was factorable by grouping. It's something that we probably didn't get to do in this. Now, what do they probably want you to do? Synthetic division on this, given that height. If x minus 3 is your factor, then 3 is your root. So let's use 3 as the root with a 2, 7, negative 18, and negative 63. We should be getting a remainder of 0, and the result of this polynomial will be that same answer. So this should, like I said, go faster, only because they asked specifically for area. 3 times 13 is 39. Add those together, you get 21, and 21 times that is 63, and you get a remainder of 0. So this, once again, gets you the coefficients for that quadratic right there, and the answer, not written in standard form on the multiple choice, is C. Okay, number 9, very last question. The number R in tens of thousands of retirees receiving Social Security benefits is represented by the function R equals 6 cubed minus 4.68 squared. And then they give it from 0 to 10. At least the domain, this is the domain that applies for this model specifically. Where T represents number of years since 2000. That means year 10 is 2010. Identify any turning points on the given interval. What does a turning point represent in this situation? This is all up to graphing calculator stuff, so I have to plug it into there. So let's go to that. My R is going to have to be Y, and my T is going to have to be X. But I got 0.286 this cubed minus 4.68 this squared plus 8.8 that plus 403. Now the T has to be from 0 to 10, so I'm going to change this window 0 to 10. I don't know what the Y's will look like. I don't think I care about negative values of tens of thousands of retirees, so I'll go 0 to something. Let's check 20 and see what this graph looks like. Nothing. Can't see nothing. It must be a zoomed in thing. This is in tens of thousands, so let's bring this down to about 4 and see if we can see the curve. I noticed that once. Oh, you know, it's plus 403. I take it back. We got to go really high up. What am I doing? Let's go to 1,000 and see what's going on. There it is. All right. Now, I don't see much from there as far as turning points. We're only looking at this interval. It says identify any turning points on the interval. Let's shrink this to like 300 to 500 or so, just to get a little bit more of a whiff of what this is doing. Oh, there is a turning point right there. And it might be turning down there as well. I can't officially tell. Okay, that looks like the very bottom. Let's make the top a little more like 403. Let's make them like 410. I really want to emphasize these turns as I think I see them. There's a top. Does it turn back? I don't think it turns back quite. There's no way to say for sure unless I zoom this thing out more afterwards. So let's start with this maximum. There's a turning point of a maximum at that top part. So let's go maximum. And let's go from 0 to, I don't know, at least 3. Let's find that height there. So there is a turning point or a local maximum. I'm going to write this on this thing as I look at it. At 1.04, 407.41. This is in what? Tens of thousands? I'm going to add some more. 41183. Okay, so I wrote this number down here. That was a local maximum. I can't tell. It doesn't look like this is a local minimum right here, but what I'm going to do is zoom out my window a little bit more to about x equals 12. I'm going to put this one down a little bit lower as well, just so we can see the fine print of the numbers. Let's go back to that graph and watch. This thing's probably going to turn again, yes, but did it turn before or after x equals 10? So in this zoom out, let's take a look at that minimum and see if this is before or after x equals 10. This is at x equals 9.869, so it is before x equals 10. So there is a local minimum. There is a local minimum. I didn't know. Now I do. Local minimum at 9.87, 308.9 3528. Okay, let's go ahead and interpret what we're looking at here. Now, R is number of retirees, or number of tens of thousands of retirees receiving Social Security benefits. So what they're saying is, after the first year, first of all, there are two turning points. After the first year, there are now tens of thousands, means when you shift that decimal place 1, 2, 3, 4 places. So it'll be 407, 4118. That's, I mean, it's approximate, around 4 million retirees receiving Social Security benefits. Okay? And this is the maximum. Let's see. There are a maximum, whatever, over from 2000 to 2010. That's probably also, yeah, from 2000 to 2010. That's after the first year, right? After what? So 1.04. Around the 10th, so after the first year, around 2001. In 2001, how about that? In 2001. Let's just do context. Nearing 2010, there are a minimum of, now this number is 3089353. I'm going to round up. 3089353. This is 3,089,353 retirees receiving Social Security benefits from, so that, from there. When I say from here, I mean that's when the minimum occurs. That's the smallest amount that we see within that time frame. That's kind of my go-to on that. So again, two turning points in total, and that's what we're seeing on that one. Okay. All right, guys, that'll do it for this one. This is Mr. Robinson. Thank you so much for watching. We got it within the hour, which is awesome. We're going to move on to Chapter 4 next. I hope that this was good. The only time that I really felt like I messed up was that constant thing. I once again can't subtract or find a difference between two numbers just fine, which is just unfortunate. There was that other problem with the volume thing. I don't get where they said the length was x, because x isn't one of the expressions that we use, and if it was, then we can't use something else to find the width and height, so I left it and let it be. I think that's okay. Guys, that'll do it for this one. Thank you so much. Take care. I'll see you in the next one.